let's say I have the curve. Now remember, area is always positive, right? It can't be negative, but integrals can be negative. Remember what the difference is? Like when integrals can go negative? Okay, let me show you. So the definition is of the integral is the area under the curve to the x-axis, right? So what's under the x-axis is negative, right? So if I had something that looked like this, and I wanted the area from, let's say, here to here, okay? Well, the area is always going to be positive, but here the integral greater than 0, integral, the integral can be negative. So here the less than. Say again? It would, but if you were asked, let's say I was asked to find the area under the curve as opposed to the integral, but I needed to use the integral because I don't know how to find the area under that, right? I can't, I mean, I could use a rectangular approximation, but that would be an approximation. But if I wanted to find the actual area, I would need to split it here so that I could find this area using the integral and this area using the integral and add them together. But this I would have to do, I'm doing the absolute value of these integrals since it's area. Does that make sense? Okay. So that's what we're going to be doing when we talk about area. So you have to graph it and look at it to tell, well, any of them that cross over, I'm going to have to cut my integral off right there, find the integral from the left down to that point, and then on, and do absolute values. Everybody okay? Okay. Let me show you an example. I have the curve y equals 4 minus x. And I want the area from 0 to 3. What is that going to look like? Okay, so it's an upside down parabola that does what? Up 4. 1, 2, 3, 4 here. And it's upside down, right? Those first couple points go down 1 over 1. You don't need that side. You're exactly right. So I want from 0 to 3. We agree? Where does 3 happen? Four minus 3 squared, 4 minus 9, which is negative 5. That's exactly right. So my 3, 1, 2, 3, 4, 5. 1, 2, 3, somewhere down here. Something like that, right? So I want the area here from 0 to 3. Correct. Okay, so I've got, well, because it's up to the x-axis. How else are you getting up to the x-axis? The area under the curve to the x. So yeah, I'm going to have to find both of these areas. See, it's the same, just like this cubic over here that we drew. It's up to the x-axis or down to the x-axis. Well, it technically is, but it's, when you flip over that x-axis, you're talking about up to the x-axis, essentially. Oh, right. Okay. Is everybody okay on how that worked there? Okay. We'll draw a couple more pictures and make sure you can get it. So here, what I'm going to have to do, this area is going to be the integral from 0 to, I need to know what this point is, right? Do you agree with that? Yeah. That's where it switches from positive to negative. How am I going to find that point? How am I going to find here? It's the 0, so I do what? What if I didn't have a calculator? Set the equation equal to 0. We're going back to algebra 2 now. Remember that? Set the equation equal to 0. So 4 minus x squared. So x should be plus or minus 2. I don't need that negative one because it's over here, right? So this should be x equals 2. So I'm going to go from 0 to 2. 4 minus x squared. Do we all agree that that would give me the area here? What about this one? 2 to what? 3. I'm going from 0 to 3, right? So from 2 to 3 of the same equation. But yeah, so this one, I know it's going to have negative area, right, or negative integral. So I'm either going to subtract it, or I'm going to know that I need to take the absolute value, whatever you need to do to understand what it is that's happening here. So let's see. Let's set this up. So the total area is going to be the integral from 0 to 2 of 4 minus x squared plus the absolute value from 2 to 3 of 4 minus x squared dx. And that's going to give me the total area, right? So it's positive because area is always positive. Now, if I just wanted the integral from 0 to 3, I could do that, and that can account for negatives, but area can't be negative. So if I'm asked area, so that's the big difference there, area versus integral. Y'all okay? All right, I need an antiderivative. Now we're going back to fundamental theorem with it. 4x minus 1/3 x cubed. I'm going to do it from 0 to 2, and I'm also going to do it the absolute value from 2 to 3. You should be able to do that, right? What are y'all showing? Oh my gosh. Oops. Eight minus 8/3. 12 minus 27, that's 9. Why? Times 1/3 minus, I could really use a calculator on this. I'm just trying to be extra. 24 minus 8. That's 3. This is 16 over 3 again. So 9 minus 16, right? You gotta do the absolute value. Well, I'm still in absolute value, but I can take it off. Right? 9, what's 9 minus 16? 16 minus 9 is negative 7, so this will be 23 over 3. That was fun. That is the answer, actually. It's really not. It's not. You just, the biggest difference here, you get to find where it crosses over the x-axis and changes from positive to negative. Y'all good on that? You think you can do that? I don't want to throw too much. I'm fixing to make it a little bit harder, and then I'll move on to the next thing. Yep. Sorry. No, you're not. I am going to put in y equals, I'm going to put that equation. What was it? 4 minus x squared? Calculate. Look at number 7.
I've seen that, but I didn't realize what it was.
Let's say that I knew it crossed over at 3, right? Isn't that where we said at 3? Lower limit, I'm going to go from 0 to 3. I'm going to find that area. Watch, it even shades it for you. But now this is giving me the area, the total area, it's saying 3. Remember, that's giving you the I shouldn't say total area. It's telling me that the integral there is 3. We know that the integral shouldn't be 3. The area shouldn't be 3. It should be 23 over 3, right? So what I need to do is I would have to do this one from 0 to 2. Correct. So from 0 to 2 is 5 1/3. And then whenever I calculate 2 to 3.
Oh my gosh.
It's a little bit. Yes, so you do the absolute value. Tim,
we don't need paper then. Use the calculator on the test. I'm gonna have to use it.
Okay, now the only thing is it's going to keep shading in for you until you delete it and regraph it, right? All right, so how did I get it? So go second trace and choose option 7, and then just do your bounds. I want to find the integral from 0 to 2. So from 0, enter 2. Absolutely. To me, this is a lot easier too than going into, because I could go math down to, what number is it again? 9. And then pull up, I'm talking about y1 in terms of x from 0 to 2. And I get the same thing, but to me, it's a lot easier to do it on the graph.
How do you get the under, like the graph, you have
There's a lot of things
on the right side and the right side?
Go from 2 to 3.
So what do you
That's why we had to do it twice. Is everybody else good on that? You understand why we had to divide it out? Do it twice. These, unfortunately, are not always calculator problems on AP, but anyway, I did wait to show you that a little while. All right. Let me show you one more example. And let me show you why you can't always count on your calculator for this. There's only 4, and this is one of them. No, we're also doing trapezoidal rule. Parabola rendition here. You get the point. Find the area of the shaded region. This would definitely be non-calculator.
You find the whole region and then drag the
That's exactly what you would do.
Yes.
If I can do the integral from pi over 6 to 5 pi over 6. Now remember, this would be a non-calculator because these are unit circle values, right? So what are you talking about triangles?
On the side.
Those ain't triangles.
No, you talking about this? You're going from here to here. Try your way and let's see if you get the right answer.
I would say go from like literally the very left point to the very right point, subtract the rectangle and the two sides.
Oh my God.
These aren't triangles. They're curves.
Yeah.
Oh, that was like
Okay, well, but you see that it says y equals sine x, and I don't draw things absolutely correct. Okay. All right. So back to this. Why don't I just find the area between the two red lines here, and then I'll subtract out the rectangle, because the area of this rectangle should be easy to find. What is it? Length times width, right? Oh, how do I find the height? And is it the same here and here? Because if it's not, then it's not a rectangle, and I may have to come in and do some. It looks the same, but we should probably check, right? This should be sine of pi over 6, and this should be the sine of 5 pi over 6. So are those the same values? All right, so I'm in the top, I'm in the first and second quadrant. Do we agree? Okay, pi over 6 we can do easily, right? Which one is pi over 6? The first one or the second one?
first one.
If I'm clicking up the unit circle, okay, what's the sine value there? 1/2. They have the same sine value. Did you use your calculator? Oh. They are both 1/2. This is also up in the top two quadrants. Okay, so the area here. I need to give y'all some unit circle practice, but you have to. All right, so I'm going to go 1/2 times, and that's the height. What's the length? 5 pi over 6 minus 1 pi over 6 would be 4 pi over 6. So 2 pi over 3. So this area is pi over 3. You agree? So I'm going to do the integral from pi over 6 to 5 pi over 6, but I'm going to subtract out pi over 3 when I'm done to subtract out that big rectangle there.
I mean, knowing those values is how you
I close my eyes and I think that I don't know them all off top like that, but I close my eyes and I have to count them and see them in my head. It's a time saver on the test is essentially what it is, because the test is timed. Yes. Just the shaded area.
Well, right now you're planning to.
But the question just asked you to find the shaded area. All right, so, well, what's the antiderivative here? So I'm going to do negative cosine x evaluated from pi over 6 to 5 pi over 6. What? If you're on an FRQ, yes.
Wait. Are you saying we have to do negative cosine from 9 on it?
Yes. I would get in the habit of doing that. Otherwise, and especially... So here we are again with these values on our unit circle, right? But we're at the same values And you know that the corresponding value there is what? Square root 3 over 2, but one of them is going to be negative for the cosine. All right, so I got negative cosine 5 pi over 6 minus negative cosine pi over 6 minus pi over 3. Shouldn't be a negative. Cosine of 5 pi over 6 is going to be square root of 3 over 2, right? But it's negative. So a negative and a negative is going to give me square root of 3 over 2. Do you agree or disagree? Plus cosine of pi over 6. Right? Are y'all with me or no?
Because I forgot that was.
I don't know
No, just once. That's just one. At 5 pi over 6, the coordinates are negative square root of 3 over 2, 1/2. Right? At pi over 6, the coordinates are square root of 3 over 2, 1/2. So it's right. Since it's negative cosine, it would be negative. So if I have a half a square root of 3, half of a square root of 3, and a half of a square root of 3, that gives me a whole square root of 3 minus pi over 3. Yes, absolutely. Let's take a brain break before we do trapezoidal.
Wait, when does spring break start?
But maybe get out. It doesn't start. So we get out early on that. Oh my God. So, yeah, y'all not aware.
I'm not trying to get school on my birthday.
All right. Let's say, and this is kind of backwards now that we know fundamental theorem. I should have done this after I did rectangular approximation. That's okay. Hindsight's always 20/20. But let's say I'm estimating the area under this curve, okay, from 1 to 2. Okay, and the curve is x squared. If I start doing rectangular approximations, remember rectangles overestimate or underestimate pretty good, right? I mean, they're not a great estimate, especially depending on how many rectangles you divide it out. Let's say I want to do this where my number of intervals is 4. You will actually have some questions that literally say, using right RAM, what is the approximate area under the curve? Well, because what integrals actually do is it's approaching an infinite number of rectangles. If you had infinite rectangles, this would be the area under the curve. Yeah. It is. That's exactly what it is. Remember whenever we were doing the summation notation and n approached infinity, that's what they were trying to get you to make a connection. Okay. So if I were to do, and let's see, that would be 16, right? N is your number of intervals. Oh, that's right. Sorry. Gosh, doggy. We're still doing yes. Dang it. This is 2, sorry. And this is 1, so I'm going from 1 to 2, not 0 to 2, right? So this is 1, 1, just to show you. This is 2, 4. Here's the area I'm estimating, right? But we know with an antiderivative and fundamental theorem, this will be easy to find. But if I were to use the rectangles here, the rectangles would they, if I did a left RAM, Right, right, because it's increasing. Okay, so I'm going to use trapezoid. Now remember, you have to know what a trapezoid is to understand why this works. What is a trapezoid? It's quadrilateral. It has one set of parallel sides, right? Parallel has two sets, yes. Okay, so if I'm dividing this into 4 sets, remember how I find the width? How did I find the width?
Wait, do we do the area?
We're going to do the area of the trapezoids, yes. But how do I find the width, what my width is here of each section? 2 minus 1, so it's A minus B, or B minus A, divided by the number of intervals you need, right? Y'all were doing this in your head, and I know this is a really easy one to do in your head, but if it wasn't, if I said go from 1/4 to 5/2, find the area in 10 intervals, you would need to know that little formula, right? That means the width of each trapezoid is 1/4. This is 1/4, this is 1/4, this is 1/4, this is 1/4. Right? This would be 1.25, 1.5, 1.75, and 2. You did. We did. Whole numbers, right? Right, right. Okay, so look, I'm going to draw a trapezoid and show you. If I come here, okay, trapezoids just have to have one parallel side. Now, this has got to be a line, but what I'm going to do is I'm just going to connect these this way. Do you see why that's a better estimate now? Here I come up, and again, it's still not exact, but it's a whole, see, I've still got a little bit of an overestimate there, but not nearly what I'd have with a rectangle, right? Correct, but it's a much closer. So now the question is, how do I find the area of a trapezoid? 1/2 times height. So I'm going to write this just a little bit differently, and I'm going to say, I'm going to put these together and say height divided by 2 times B1 plus B2. Now let's think about this for just a minute. Where is my height and where are my bases? Let's look at just this trapezoid here. Okay, so when I said width here, what I really found was the height of the trapezoid, right? Isn't that 1/4? But I'm going to show you a general formula. I want you to understand why, but I'm going to show you a general formula. That is the height. The two bases have to be the two parallel sides because those are what's going to have that varying length there. So it's just turned on its side. That's exactly right. B1 and B2. Okay? Are y'all with me? Okay. So I need these coordinates here. This would be 1.25. I'm just going to put x squared, my calculator, go into the table. I hope y'all are used to using that function on your calculator, yes? If you put it in y equals and then you just go into your table to plug in values of x, do you know what I'm talking about? Let me show you because this is a huge time saver. If I put y equals x squared in my calculator, and then I go second graph, I'm in this table, and any value that I want to know the y value for. So I had, remember I started at 1, and then I went 1.25, 1.5, 1.75, up to 2. Those are all the y values. So I don't actually have to go into, I don't have to say what is 1.25 squared. All right, what do we do now? Look at this first trapezoid and tell me what the area of the first trapezoid is. What is H? Whoa. H is 0.25. So I've got 0.25 over 2 times, that is. Always take it out 3 or 4. 4, take it out 4. The Y value there was 1.5625. Okay, so look what's going to happen, and I'm making a point with this to take the time to do this because you're going to understand the formula a little better. All right, so I'm going to do base 1, which is 1, plus base 2, 1.5625. That's the area of that trapezoid. Do you agree? And then if I do the area of this trapezoid, the height is constant. Do you agree? So every single time I'm multiplying by 0.25 over 2, right? Times. Now what's base 1 here? Do you notice that it's the same thing? Right. And then this is 2.25. Yeah. So this looks like a lot, right? Yes, and that's exactly what we're going to do. So I'm going to say to find the trapezoidal area, I'm going to do the height divided by 2. Now remember, height we found by saying B minus A over N, right? Remember that? And I'm going to multiply it by. So instead of doing it to each one and then adding them together, I'm going to say, okay, I'm just going to multiply it by the whole thing. I'm going to essentially factor that out, right? I take the very first base, but I'm taking the Y value there, right? So I'm going to call this Y sub 0. Don't let that throw you. That's just the very first base. Okay? Plus, well, if this is Y sub 0, this is what? Y sub 1. But whenever I move to the next one, look, it's the same. I'm going to have 2 of them. So 2Y sub 1 plus 2Y sub 2, and I'm going to keep with this pattern until I get to the very last one. I'm going to call it Y sub n. But I'm only going to need one of those, right? Because the 2 n's I just need one of.
Like it said go between these intervals 1 to 2, 2 to 4, and then like 4 to 6, and then like you have the 2's overlap and the 4's overlap. Does that make sense?
No. I will look at it though. I'll look at it. All right. Does this make sense?
We can still like if we want to.
Yeah, you can. It just might get long, but you can. If you do it a couple times that way where you add them up, you'll see where the formula's coming from a little better, and then you'll go, wait, this is silly. Especially if you've got a table with the values. Remember whenever we were doing the rectangles, how it was, you went, oh, I just do width times this plus this plus this. It's going to be the same scenario. You're going to start doing it, and then you're going to go, wait, this is silly. I do. This would be, right, so this would be, this is y sub 0. This is y sub 1. This is y sub 2. This would be y sub 3. So you'd go up to y sub 4. So you'd double this one, and this one. Here, I'll do this one using the formula and show you. What was y sub 3 here? 3.0625. And then this would be 4.
You can make it a fraction.
Either or. Trapezoidal area within subintervals would be here, or actually, we're doing the trapezoidal area with, how many subintervals did we say? 4? I'm going to just say sub 4 here, so I know I did it with 4. The height was 0.25 divided by 2, that's my h over 2, times 1 plus 2 times that 1.625. Thank you. Wow. 30625. Weird? I'm sorry.
I think I started incorrect. I started the bottom of the board.
1/4 divided by 2 would be 1/8, right? One plus. This is fun. It's not hard, it's just tedious.
I actually I don't feel too worried about that.
If you're on the AP exam, make sure you go out 4 decimal places. I think it's 3, but go 4 to be safe, and I'll look it up.